introduce themselves.
All right. Good morning, everyone. Welcome to Aquaventure Engineering Incorporated's D80 presentation. Today we'll be presenting about the Quebrada Pastor water system that we've been going and analyzing for the village Quebrada Pastor in Panama. My name is Angelina Crispo.
I'm Maggie Ziols.
I'm Benoy.
And I'm Colleen Carbary. So just a quick outline of our presentation. We're going to go through and talk a little bit about International Senior Design Program and how we went and traveled to Quebrada Pastor. While we were there, we really truly gained a good cultural understanding of the village that we were in. And then we also identified some design aspects that we were going to be working on for our senior design here this fall semester. Wrap it up with some conclusions, and then have a few minutes left over for questions. So International Senior Design is a 2-semester, 6-credit senior design option. For the first, during the summer, we had 2 weeks in Panama, and we actually spent a full about 7 days in the village. We were working on designing solutions to problems in the village, and our group specifically analyzed the water distribution system in Quebrada Pastor. We worked really closely with the Peace Corps volunteer in the villages. They kind of helped guide us through the village, work as translators, and really help kind of gain a good cultural understanding in our quick 7 days in the village. And we really also worked a lot with having community support in order to make sure that they were involved with as many aspects as possible.
Right, to give you a visual of basically where we started and where we ended up, we started as a group of about 20 with 2 advisors in Panama City, and then we traveled about 9 hours to the city of David, and then that's kind of where we split up into our individual groups of 4 or 5. And our group traveled from David up to Quebrada Pastor, which is located on the Caribbean coast in the region of Bocas del Toro. So to give you a background of Quebrada Pastor, it's a community of about 800 people within about 100 homes. A big change in the community happened about 1999 when they built a large highway basically through the center of town. That had a big impact on the culture and the ability to get to larger cities and get different goods. There's 2 churches in the community, along with a school and some small businesses. Some sources of income are fincas, which is basically a large plot of land used for farming. This is where they grow cash crops such as yuccas, bananas, and cacao. Another source of income is through tourism. There's the island of Bocas is very nearby, and that's where people sell their cash crops or work other domestic service jobs. So like I said, cacao is a large source of income for the community. One of the largest suppliers, his name is Willie, and this is us on a tour of Willie's chocolate factory. We spent one of our last days on getting a tour of the entire cacao process. So we started up in on his finca, which is basically like a chocolate jungle. There was cacao hanging from all the trees. We got a cut inside of them, and you see these seeds, which we picked out of cacao, and then roasted those seeds and grinded them up. There's Derek inside the factory grinding them up, and the finished product is this little puck of cacao. And so when cacao is melted down and mixed with sugar, this is what chocolate is.
So a big part about iDesign is getting to experience another culture. And we were actually fortunate enough to get to stay with the host family while we were down there. Picture in the upper right, that's our host family. Our host father, Lucas, and his wife and kids and grandkids. And they allowed us to go into their house and take over 2 rooms and put up tents and bug nets and just put stuff everywhere. And they probably thought we were crazy, but they're really understanding of our cultural differences. And they took really good care of us. They made us chicken soup one night, which anytime you have meat down there is kind of a big deal. And we also just got to know them better and got to see kind of how they live their every day-to-day lives. So this is our Peace Corps volunteer, Alex. She's the whole reason we were able to come down and do this project, and she was really supportive. She has a background in engineering, and so that was really helpful because she already had like a project in mind that we could do the amount of time we were down there for. Her whole thing all week that she stressed was that sustainable development is empowering. So by teaching the people to build these things and maintain these projects, that goes a lot further than just giving them a project where if something breaks, they're not going to be able to do anything about it. She did leave halfway through because she had some other obligations in Panama City. But we also had Carissa, who was a student or a tech alum mentor that did iDesign in the past and also speaks pretty good Spanish, so that's a lot of help.
So as we've mentioned, our senior design project was to analyze the aqueduct. So this aqueduct in Quebrada Pastor was originally built in 2002 by the families and the villagers and was funded by the government. We have 3 1,500-gallon storage tanks as well as 2 spring sources slightly up the hill from the village. Initially, it was built to service the school as well as 8 connections, but now we have over 30 homes on it as well as the school, the church, and then Lily's chocolate factory, the Heidi's Organic Chocolates. And to control this line to determine how much people pay as well as when we shut it down, the Directiva goes and runs it.
So Directiva is what the community refers to as a water committee. This was something that was really unique to our community. They're a highly functioning organization. They're really motivated to keep this aqueduct running, which is really cool and a really nice thing to work with. There's about 6 executive board members with roles similar to those that you and I are familiar with, such as a president, a secretary, a treasurer. The treasurer is obviously responsible for the funds. So the funds for the aqueduct come from charging users $3 a month. This excludes the school. So if you do not pay this payment every month, your line basically gets cut and you're responsible for getting yourself back on the line. Another really vital role is the operator. He's responsible for all the maintenance and repairs. He's basically on call every day, controlling the flow of the system and making sure the school always gets water. And he gets paid about $20 a month to do this.
So I talked a little bit about how supportive our host family was, but really the entire community was really helpful. Every day we had at least one community member with us helping us survey, machete through jungle and locate the line. This picture is Lucas, our host father, helping us dig a hole so we can take some flow measurements and water quality samples. And even the rest of the community. I remember one morning it was this full-on downpour, and it rains every day, but this morning it was just like torrential downpour. And so one of the women invited us into her home and made us coffee, and we just chatted until the rain slowed down. It was really helpful. And then I know Colleen and Maggie went around and did some interviews, and everyone was really welcoming and willing to answer all their questions.
So like Derek just said, we went around and interviewed the villagers. We tried to talk to as many people as we could in the community. We really tried to talk to people from each of the sections of that service, the aqueduct services, to kind of understand, okay, maybe this part, they don't receive water every day, or this group here are having pressure issues or something like that. We also talked to each member of the Directiva. We wanted to fully understand each of their roles, their involvement in the aqueduct system, and what sense of ownership and responsibility they have for their system. The system operator, we had a really long interview with, and we talked to him and tried to get some of his thoughts and ideas on how we can improve the system, and also to understand how he thinks it is best to control the system, and also just kind of gain what he thinks would help improve the most. Like we have said, the school has been the most important aspect for the aqueduct, and that's what the water is mainly going to try to be used for. So we've sat down with the principal at the school, and we really tried to understand the uses for the water at the school, how many kids that they are coming to the school every single day, and while they're at school, they do receive one meal and also a snack, which is a huge aspect for where the water goes. We also just try to determine some demands at the school as well. And then probably the most interesting interview that we ended up having is we talked to the women who cook and work at the school. At first they were pretty reluctant to give us their opinion, but they offered a very different approach. They thought that we can do some of these technical improvements to the line, but they really felt that it was through education that we're going to make some major improvements. Telling kids that they're not to play on the line, teaching kids how to not waste water, and then also just kind of a big understanding that it's a privilege to have the aqueduct bring water to the school for them every day. A lot of the questions that we asked were about demand, how many people are living in your home, and stuff like that, and also the uses. The uses are pretty universal. Number one is always cooking, and then bathing yourself, and then washing clothes. These interviews were a huge aspect to the cultural understanding. We only had 7 days there, and we were just trying to get as much information as possible. But these interviews really help determine the cultural and societal constraints that we're going to be put onto our design project.
And so for our design project, we had to go and gather data in order to identify some of the different design objectives and areas that we could go and really help out this aqueduct. We encountered some problems since we weren't really fluent in Spanish. We relied heavily on Alex as well as Carissa to kind of help translate for us, as well as plenty of pantomiming and just trying to go and learn Spanish and then also teach the villagers that were with us surveying also English, just becoming familiar with surveying. We used a lot of different pieces of equipment. We used avenue levels as well as rangefinders to go and survey the line, which we weren't really familiar with. We also sometimes had to use machetes, like Derek is here, to go and kind of dig around, find the line. And then in this picture, Derek is using it to kind of dig a hole so that way we could get a flow measurement from the Toma over here. We also did some water quality testing as well as interviews to go and then determine all of the needs of the system so we could come back and design it here in the fall.
So to go into some of these design objectives, a toma is a Spanish word for a spring box, and if you're not familiar, a spring box is a structure built to capture water from a natural spring source. There are two tomas that feed the entire aqueduct. One of them was built by the Panamanian government, and the other one was a group effort by the community. And the Toma number one, the government one, is pictured here. So Toma number two doesn't exactly follow the standard design of a Toma. It lacks a primary filtration and capture area as well as a secondary filter. It's basically just like a big reservoir. And one of the largest problems is that it's not sealed off, and this is causing a lot of sediment buildup in the tank, in the reservoir, which is causing the water to be super turbid. So we did some water quality tests. We did a rapid coliform test. These are the Petri films. If you're not familiar, coliform is an indicator of contamination. So you can see by the averages, Toma 1 is a lot lower than Toma 2. So moving forward, one of our design objectives is going to be to design the proper sealing of Toma 2 to not only increase the water quality, but decrease the sediment buildup so that there can be more flow into the aqueduct.
As we move down the line, the next objective that we're looking at is the stream crossing. So in total, there are 2 stream crossings throughout the entire system, but this is the one that's in the worst shape. As you can see, this metal is almost completely degraded. And if this were to break or snap, it would completely shut down the supply of the water throughout the entire system. So what we're looking at is working on constructing a different type of support constructed out of concrete and masonry blocks.
So there's currently 5 control valves on the system, and basically this just allows them to turn the water on and off at these various points. So as part of the project, they wanted us to make suggestions on where we should install some more control valves. So through our EPANET model, which I'll talk about a little bit later, and talking with the operator, we made some suggestions such as installing them before these tanks so that they can close the water off, go and clean the tanks, so that they have as clean water as possible, as well as at all the different service lines so they can regulate the pressures better.
And they have to regulate the pressure because not everybody does get water every day. We have a lot of areas where the pipe is unburied. So as you can see over here, the kids are trying to force the pipe back together to kind of fix that break. So because people have it exposed, animals and people will climb on it, trip over it, kids will play on it. So this can lead to a lot of problems with the pressure in the line as well as everybody's ability to go and get water. And since the school is priority so that way they can feed the students those meals during the day, the Directiva has a schedule roughly of what lines they're going to shut down to make sure that the school will always get the water it needs for the food.
So like we said, the school is the main priority for water supply from the aqueduct. For that reason, we spent a lot of time with the school interviewing people. Through those interviews, we found out they give us a rough estimate about 1,000 gallon per day use. This is towards cooking and drinking. We also found out that there's currently 2 1,500 gallon rainwater catchment tanks at the school, but that these tanks are not in use because they were abused by outside members. So to kind of make an example of that, they wanted to fund money to fence off these tanks so they would only be used for the school. So we did some analysis using rainfall data from a nearby area of Changuinola. Along with this rainfall data and the catchment area of the roof and the roofing material, we were able to come up with a supply that could potentially be delivered to the school from rainwater. So from this analysis, we kind of got a rough estimate that about 50% of the demand of the school could be met just from rainwater. So moving forward, we want to recommend that the school rely more on rainwater than the aqueduct, because currently their first go-to source is the aqueduct until it's depleted, and then they would go to rainwater.
So this is our EPANET model, and what EPANET is a modeling software used for water distribution systems. So you can model anything from like a big city where there's a lot of pumps and tanks and many houses to what we had, which is a gravity-fed water distribution system. And this was really helpful in being able to visualize, what exactly the system was doing. We took all our survey data, all our elevations, our distances, and put them in the program. And it tells us things such as pressure and head loss and velocities. And you can even change it so that different things are represented by different colors, and you can see how the system changes throughout an entire day. So this was really helpful in making decisions for our design project.
So in conclusion, while we were there in Panama, we surveyed over 14,000 feet of pipe, servicing 30 homes, a church, the school, and also the small business. We're really going to be focusing on improving the source, the volume supplied, and also the control throughout the system. We really loved experiencing Quebrada Pastor. All of us fell in love with all of the people in the village. They were so accommodating and so loving. And we are really looking forward to sending our report here at the end of the semester back to the Peace Corps volunteer in the village, and then hopefully she can go forward and implement all of those designs to make sure we're really helping out the people that we fell in love with.
We'd also like to take this time to thank both Mike and Dave, who are our advisors through this, as well as Carissa, our mentor, and Alex, our Peace Corps volunteer. And we'd also like to thank you for listening to our talk today. Are there any questions?
Time for a couple questions. Well, we have to ask at least one question. What would you have done differently, knowing what you do now? Would you have prepared differently for the trip, or would you have carried out some different assessments while you're in the community?
I don't think we could have prepared anymore, really.
I think probably it would have been a little bit better for us to maybe play around on the internet and learn a little bit more Spanish, as well as kind of focus on like the engineering specific words, as well as surveying terminology, and then probably forming a better description of what it was we needed for our surveying, because that was kind of a majority of both Derek's and I problem when we were surveying was, how do we tell them that we want to like move down the hill or have to go and do a turning point? Like, how do we say that in Spanish? So probably practice our Spanish a lot more.
For me, I fell down a lot, and I fell down a lot in Panama because it's muddy and I don't do well on land. So, I don't know, with that, I guess I should have practiced trying to walk in mud, I guess.
Through Berkeley times during
Yeah.
the rainstorm.